moon has always suffered from the elegance of distance. Seen from Earth, it appears serene, almost ceremonial, a pale and faithful presence keeping watch above tides, myths, calendars, and sleepless windows. It has inspired prayers, songs, prophecies, and ambitions precisely because it seems so near, so cleanly held within sight. Of all the worlds beyond Earth, it appears the most available to longing. That familiarity is deceptive. The moon is close in astronomical terms, but it is not gentle. It is a hostile domain stripped of nearly every protection that makes human life ordinary. To imagine living there is to confront a version of existence in which the smallest safeguards of Earth suddenly become luxuries beyond price. Air is gone. Weather, in the earthly sense, is gone. Pressure is gone. Blue distance is gone. The body would not step onto a neutral frontier waiting politely for settlement. It would enter an exposed mineral desert where radiation falls hard, temperatures swing with astonishing violence, dust clings like poison, and silence is broken only by the machinery required to keep death from becoming immediate. The moon is not merely barren, it is actively indifferent. That indifference is what gives the lunar dream its dangerous glamour. Human beings are drawn to the idea of a nearby colony because nearness suggests manageability. It tempts the mind into thinking that the moon might be a harsher desert, a more technical Antarctica, a place difficult but governable. The truth is more severe. A lunar base would not be a town placed on an empty plain. It would be an artificial refuge built inside an environment that remains lethal every minute of every day. Outside the walls, the moon offers almost nothing a human body can use. Inside them, every breath, every degree of warmth, every liter of water, every watt of energy would exist only because a fragile system continued to function without interruption. The first terror is the absence of atmosphere. On Earth, air is so constant that it becomes nearly invisible to thought. It is not just what we breathe. It is the medium that softens temperature, scatters light, slows meteoroids, carries sound, supports combustion in controlled ways, and wraps the planet in pressure that allows liquid water to remain stable at the surface. The moon has almost none of this. Its exosphere is so thin that for practical human purposes it offers no shielding, no breathable reserve, no weathering cushion between a living body and open space. This means a lunar habitat cannot rely on partial adaptation. It must create an entire pocket of Earth-like conditions against a world that supplies none of them. If a door seal fails, if a hull is punctured, if a suit tears, the danger is immediate. Pressure loss is not a dramatic inconvenience, it is catastrophe. The moon does not forgive small errors because outside the engineered envelope there is no forgiving medium at all. There is vacuum, and vacuum is not empty in the poetic sense. It is the absence of every ambient mercy on which terrestrial life depends. Even psychologically, that matters. On Earth, open the door and there is a world waiting. On the moon, open the wrong door and there is only exposure. The difference would press inward on the mind day after day. Every wall, every seal, every redundant system would carry the emotional weight of a frontier between life and instantaneous peril. Home would not feel like shelter in the ordinary sense. It would feel like successful containment. Then comes radiation, one of the most relentless dangers in any long-term lunar settlement. Earth is protected by both a magnetic field and a substantial atmosphere. Together, they blunt much of the constant assault of cosmic rays and solar particles. The moon possesses neither protection in any robust human sense. Its surface lies far more exposed to high-energy radiation, especially during solar events that can flood space with dangerous charged particles. A brief mission can manage that risk with timing, shielding, and luck. Permanent habitation is another matter. Over months and years, radiation becomes not an episodic hazard, but a chronic condition of place. It threatens DNA, increases cancer risk, damages tissue, and poses special danger to the central nervous system and reproductive health. A colony would therefore need shielding not as a luxury, but as an architectural principle. Habitats might have to be buried under regolith, tucked into lava tubes, or protected by massive engineered walls simply to bring exposure down to something vaguely tolerable. This changes the dream immediately. The romantic fantasy of glass domes and panoramic lunar horizons collapses under the arithmetic of radiation dosage. The safest moon base is unlikely to be the one that looks most open to the stars. It may resemble a buried installation, inward-looking and fortified, with only brief excursions to the surface. The moon invites humanity upward, but it may force any lasting human presence to live underground like a cautious species rediscovering the logic of caves. The lunar dust, known as regolith, introduces another threat far less glamorous and perhaps more intimate. At first glance, it resembles ordinary dust or powder, a fine layer spread across an ancient landscape. In reality, it is abrasive, electrostatically troublesome, and chemically unpleasant. Because the moon has no atmosphere and no flowing water to soften grains over geological time, the particles are sharp and jagged. They do not weather into the gentler forms common on Earth. They remain broken, angular, and eager to cling. Apollo astronauts brought some of this dust back into the lunar module, and it quickly proved difficult to manage. It adhered to suits, equipment, seals, and interiors. It smelled strange. It irritated lungs and eyes. In a future colony, regolith would not be a minor housekeeping issue. It would be a persistent engineering and medical concern. Dust carried inside could threaten machinery, degrade moving parts, contaminate air systems, and expose inhabitants to chronic irritation or toxicity if not rigorously controlled. Imagine a settlement where every excursion outside returns with a cloud of microscopic abrasion. The suit ports, airlocks, filters, brushes, and decontamination systems would become as important as food storage. Fine lunar dust would settle into fabrics, joints, hinges, and habits. It would not merely coat the world outside. It would try, incessantly, to enter the human refuge and wear it down from within. Temperature is another kind of cruelty. On Earth, air and oceans transport heat, smoothing extremes across time and geography. The moon has no such moderation. In sunlit regions, surface temperatures can rise to punishing levels. In darkness, they can plunge with equal ferocity. The long lunar day and long lunar night intensify this pattern, creating cycles of heating and cooling far harsher than ordinary terrestrial experience. For a habitat, this means thermal control must be exact and continuous. Structures exposed to sunlight may overheat severely, while shaded surfaces can fall into deep cold. Materials expand and contract. Equipment must endure stress. Power systems must bridge long periods without sunlight unless the base is placed in carefully chosen polar regions where illumination is more favorable. Even then, local geography and shadow become matters of survival, not scenic detail. The deeper psychological consequence is that the moon offers almost no passive comfort. A human colony cannot simply endure the climate with better clothing and disciplined habit. It must actively generate habitability every hour. Heat, cooling, insulation, storage, circulation, and power are not conveniences added to a neutral home. They are the machinery by which home exists at all. Water, so common on Earth that entire civilizations were built beside it, becomes on the moon a matter of extraction, purification, rationing, and relentless accounting. There is evidence of water ice in permanently shadowed craters near the poles, and this has made polar settlement especially attractive in current planning. But accessible ice is not the same thing as a ready lake or a dependable aquifer. It is a resource that must be located, reached, mined, processed, protected from contamination, and integrated into a larger life support economy. A lunar colony would need water for drinking, hygiene, oxygen production, agriculture if agriculture were attempted, and possibly fuel production if hydrogen and oxygen were separated for propellant. That makes water both a biological necessity and a strategic asset. Its management would shape the settlement's geography, politics, and viability. A failure in water recycling would not merely inconvenience life, it would threaten the colony's continuation. This is where the moon begins to reveal a truth harsher than distance alone suggests. Even the most elementary substances of life do not simply await us there in accessible form. They must be hunted, extracted, and husbanded with a seriousness unknown to most of modern terrestrial living. To exist on the moon would mean living within an economy of survival so exact that waste itself becomes a moral and technical failure. Food adds another layer of difficulty. Early lunar settlements would almost certainly depend heavily on supplies from Earth, supplemented perhaps by tightly controlled greenhouse systems or other forms of closed-loop cultivation. Yet growing food on the moon is not equivalent to building a remote farm. Agriculture depends on light, water, nutrients, atmospheric control, biological stability, and significant space. Each of those requirements becomes a systems problem under lunar conditions. A greenhouse on Earth is a specialized enhancement to a living planet. A greenhouse on the moon is an ecosystem standing against vacuum and radiation. Every pest outbreak, fungal contamination, pump failure, or nutrient imbalance would carry amplified consequences because redundancy is expensive and resupply is slow. The romance of lunar gardens, while not impossible, often conceals the degree to which such gardens would be laboratories first and pastoral spaces only secondarily. Even eating would feel different in a place where every calorie has a logistical history. Food would not arrive through ordinary chains of abundance. It would arrive through launches, inventories, growth chambers, and exact planning. The colony's table would be inseparable from the mathematics of mass and cargo. Hunger on the moon would not come from a failed harvest season alone. It could come from launch delays, mechanical breakdowns, and the cumulative fragility of closed systems. Isolation may prove no less dangerous than any physical hazard. The moon is near enough for signals to travel quickly by cosmic standards, yet far enough that rescue is never immediate and return is never trivial. A lunar colony would live with a strange dual consciousness. Earth would remain visible, beautiful, and emotionally dominant in the sky, yet unreachable in the casual sense. No one would step outside and decide to go home that afternoon. Every transfer would require vehicles, launch windows, fuel, planning, and favorable conditions. This produces a psychological burden unlike that of ordinary remote habitation. Polar stations on Earth, submarines, and orbital stations already teach us something about confinement and distance, but the moon intensifies all of them. The settlers would know that beneath the poetry of exploration lay an absolute physical fact. Their world is not self-sustaining, and their nearest true biosphere hangs above them as a luminous reminder of dependence. Earth would not simply be home, it would be the lost abundance visible through glass. Confined communities under stress develop tensions even in favorable conditions. On the moon, such tensions would coexist with lethal environmental stakes, strict routines, restricted space, and the constant awareness that any major systems failure could become collective danger. Mental health would not be a secondary issue handled after engineering. It would be central to survival. A colony might fail not through one dramatic explosion, but through the slower erosion of trust, resilience, and emotional endurance. Low gravity introduces its own long-term uncertainty. The moon's gravity is only about 1/6 of Earth's. This may sound appealing to the imagination, promising ease of movement and a kind of playful liberation. But the human body evolved under Earth gravity, and long exposure to reduced gravity is associated with muscle loss, bone demineralization, fluid shifts, and other physiological changes already observed in spaceflight. Lunar gravity is greater than microgravity, but whether it is sufficient to preserve long-term human health remains uncertain. That uncertainty shadows any serious vision of multi-year or multi-generational habitation. Can children develop normally in lunar gravity? Can adults maintain cardiovascular, skeletal, and reproductive health without elaborate countermeasures? Can a true population, rather than a rotating staff of specialists, endure there? At present, no one can answer these questions with confidence. A permanent colony would therefore be built in partial ignorance of what its environment might gradually do to the body. This is a subtler nightmare than vacuum or radiation, but perhaps a more intimate one. A hostile world is one thing. A world that slowly rewrites the human organism is another. The moon may not merely threaten life from the outside. It may ask the species to discover in real time how much of its own biology depends on the gravity of Earth. Micrometeoroids and infrastructure fragility add yet another layer of danger. Without a substantial atmosphere, the moon cannot burn up incoming debris the way Earth does. Small particles strike the surface directly, and while individual impacts may be tiny, their velocity can make them destructive. A settlement would need shielding not only against radiation, but also against constant particulate threat. Habitats, vehicles, power systems, communication arrays, and suits would all require protection, inspection, and maintenance. This is where lunar life begins to resemble siege engineering. Nothing can be left casually exposed. Redundancy becomes law. Components must be replaceable. Spare parts must exist. Repair capacity must be local because dependence on Earth for every failure would make the colony brittle. The moon punishes fragility not out of malice, but through the simple continuity of physical exposure. Every settlement eventually develops an illusion of normalcy. That illusion would be dangerous on the moon. The systems could function so reliably for months that life might begin to feel routine, almost civil. Yet outside the walls, conditions would remain absolutely unchanged in their hostility. One puncture, one severe solar event, one cascading technical failure, and the entire emotional atmosphere of ordinary living could collapse back into emergency. And still, for all this severity, humanity may go. That is part of what makes the lunar future compelling. The moon is hostile, but it is also close enough to tempt ambition, science, industry, prestige, and the ancient human desire to cross thresholds simply because they exist. Bases may be built, mines may be attempted, laboratories may flourish. Some form of settlement may indeed take root there, yet if it does, it will not succeed because the moon welcomed life. It will succeed because human beings learned how to construct an island of Earth conditions inside a world that refuses them. The dream of lunar living often borrows its emotional force from images of first footsteps, silver horizons, and the planet Earth hanging brilliant above black sky. Those images are real, and they deserve their power. But a lasting colony would be defined less by the beauty of the view than by the discipline of maintenance. Filters changed on schedule. Radiation shelters kept ready, water cycles closed, dust excluded, psychological strain managed, power conserved, air retained. Survival would not be cinematic most of the time. It would be procedural. That may be the deepest correction the moon offers to human fantasy. The nearest world beyond Earth is not a waiting paradise, nor even a rugged frontier in the old terrestrial sense. It is a place where civilization would have to be manufactured continuously against vacuum, dust, isolation, radiation, and cold. Living there could indeed become possible, but it could also remain in every meaningful way, a nightmare held at bay by engineering, vigilance, and the refusal to make mistakes in a landscape that never stops punishing them. Power may be the least romantic problem of all, and yet it governs almost everything. A settlement on the moon would not simply need electricity in the casual terrestrial sense. It would need uninterrupted energy for life support, heating, cooling, communications, computing, water recycling, food production, dust management, medical care, mobility, scientific equipment, and emergency reserves. On Earth, a power outage is usually temporary discomfort, economic loss, or local danger. On the moon, it could become a countdown. If energy fails long enough, the habitat ceases to be a habitat and becomes a sealed container waiting to equalize with a lethal environment. This is why the choice of landing site matters so much. Polar regions are attractive not only because of possible water ice, but because some elevated areas receive sunlight for unusually long periods. Even there, however, power planning would demand redundancy, storage, careful distribution, and the acceptance that every watt matters more than it does on Earth. Solar arrays would need cleaning, positioning, maintenance, and protection. Batteries or other storage systems would need to survive repeated cycles and harsh conditions. Nuclear options, if used, would introduce different engineering and political complications. There is no effortless solution. Power on the moon would not be infrastructure in the background. It would be a daily strategic concern. The psychological consequence is easy to overlook. On Earth, people live mostly unaware of the electrical metabolism sustaining them. On the moon, the awareness would be constant. Light in the corridor, air in the module, heat in the sleeping quarters, pumps in the water system, oxygen in the life support loop, all of it would be visibly dependent on stored and managed energy. Modern life hides its machinery. Lunar life would expose it. Every human comfort would feel tethered to a visible chain of technical continuities that could never be fully forgotten. Sleep, too, would change in ways that sound minor until one imagines them over years. The moon offers no atmosphere to soften light, no weather to create familiar seasonal moods, no natural soundscape of wind, rain, birds, distant traffic, leaves, or water. Outside the habitat, there is silence in the strict mechanical sense. Inside, there would be fans, filters, pumps, regulated airflow, electronic tones, maintenance sounds, and the persistent hum of systems whose function is survival. Rest would take place inside an artificial acoustic climate. Circadian rhythm might also become a problem, especially away from carefully controlled lighting. The lunar day-night cycle is not naturally suited to human biology. Habitats would need to manufacture time as deliberately as they manufacture breathable air. Light would have to be programmed, not merely switched on. Work shifts, sleep windows, communal routines, and mental health protocols would all need to compensate for the absence of a naturally supportive external rhythm. Human beings would not merely inhabit a new place. They would inhabit a place in which one of the oldest regulators of life, the ordinary Earth cycle of day and night, no longer offers reliable guidance. Over weeks, that may seem manageable. Over years, it becomes civilizational. A colony must not only keep bodies alive, it must make time livable. It must decide what morning means when the world outside does not offer an intuitive morning, and what night means when darkness is not a local event but a wider cosmic condition. The moon may therefore challenge not just engineering, but the ordinary human choreography of waking, working, resting, and recovering. Medicine on the moon would also exist in a harsher register than the romance of exploration usually admits. A settlement might begin with healthy, highly selected personnel, but no community remains permanently ideal in biological terms. There would be infections, accidents, fractures, dental emergencies, burns, mental breakdowns, equipment injuries, toxic exposure, and the possible long-term effects of radiation and low gravity. Every medical problem would unfold in a place where outside evacuation is complicated, delayed, and resource-intensive. That means a lunar outpost would need a standard of medical autonomy far beyond the ordinary idea of a remote base. It would need diagnostics, pharmaceuticals, sterilization, surgery capability, or at least advanced trauma response, telemedicine support, trained personnel, emergency isolation procedures, and reliable stocks of everything from pain management to antibiotics to replacement components for medical equipment. Even then, there would remain cases for which no perfect response exists. A serious internal injury on Earth is already frightening. On the moon, it occurs inside an environment where every layer of care depends on finite supplies and where transfer home cannot be improvised. There is also the question of birth, childhood, and aging. A true colony, rather than a rotating industrial or scientific station, would eventually confront them. How would pregnancy proceed in low gravity? How would infancy adapt? How would growing bones, immune systems, and neurological development respond? What happens when the elderly exist in a place where every system is engineered for survival efficiency? These are not cinematic questions, but they are decisive ones. A civilization is defined not only by how it arrives, but by whether it can sustain the full arc of human life. Mobility on the moon is another source of stress that the imagination often underestimates. On a world with no atmosphere, no roads in the ordinary sense, extreme dust, sharp temperature gradients, and long distances between useful locations, movement is not a casual matter. It requires suits, rovers, energy, route planning, communication support, and a constant awareness that a small technical failure far from the habitat may become life-threatening with terrible speed. The surface may look open, but openness on the moon is deceptive. It is not freedom, it is exposure. A short journey can require layers of preparation that feel disproportionate by terrestrial standards. Every wheel, seal, visor, oxygen line, battery unit, navigation system, and communication relay becomes part of the possibility of returning alive. Even in low gravity, fatigue, disorientation, suit limitations, and environmental monotony could make travel more dangerous than the clean horizon suggests. This would reshape the meaning of distance. A crater rim visible across a plain might appear close enough to walk toward, yet in real operational terms it could be remote, costly, and risky. Lunar geography would not be read through ordinary instincts. It would be read through life support duration, terrain stability, signal continuity, and the margin for failure. A colony's map would not just show space, it would show survivable reach. The problem of construction is equally severe. A permanent lunar settlement cannot remain forever a collection of landed modules. Over time, it would need expansion, reinforcement, shielding, storage, repair zones, industrial space, perhaps buried habitats, perhaps laboratories, greenhouses, garages, and processing sites for local materials. Building all that on Earth is difficult enough. Building it on the moon means working in suits, in dust, in low gravity, under radiation, with highly limited margin for improvisation. Imported materials would be extremely expensive in mass terms, so any serious long-term settlement would be pushed toward using local regolith for shielding, bricks, sintered surfaces, or structural feedstock. That sounds elegant in theory, but it transforms the colony into an industrial experiment. Machines must work reliably in abrasive dust. Processes must function in low pressure or inside controlled facilities. Construction errors become costly because repair logistics are harsh. It is one thing to imagine a futuristic base appearing on the moon. It is another to imagine the endless labor, maintenance, fabrication, and iterative failure that would actually produce it. This is where the nightmare becomes less dramatic and more persistent. The colony would not only fight the environment through life support, it would fight it through every wall added, every tunnel reinforced, every storage volume expanded, every landing pad stabilized. Settlement is not a single achievement. It is a prolonged argument with place. On the moon, that argument would be conducted against a terrain that offers no forgiving middle ground. Economics would create another layer of pressure. A lunar settlement is often described in terms of science, exploration, prestige, or destiny, but none of those erase cost. Cargo mass matters, launch cadence matters, resupply matters, spare parts matter, human labor time matters. Any settlement intended to survive beyond symbolic demonstration would eventually face brutal questions of efficiency. What is produced locally? What is imported? What justifies the expense? Which missions are scientific? Which are industrial? Which are political? Which are military? And which are simply too costly to sustain? This is not a secondary concern. It would shape daily life. The difference between a glorious outpost and a brittle one may come down to whether its material flows are realistic. If a colony depends too heavily on Earth for essentials, it remains vulnerable to launch failures, economic downturns, conflict, and changing political priorities. If it tries to become self-sufficient too quickly, it may overburden immature technologies and force colonists into a constant struggle against scarcity. The moon punishes bad economics because bad economics become bad engineering, and bad engineering becomes danger. One can imagine the emotional effect of living in such a place. Every object would have a cost traceable across millions of kilometers of logistics and energy. Waste would feel different. Repair would feel sacred. Consumption would lose its terrestrial innocence. Abundance would no longer be a cultural assumption. It would become a difficult accomplishment, always threatened by the mathematics of distance and mass. Politics would arrive just as surely as engineers. No settlement inhabited by humans remains purely technical for long. Decisions about command, resource allocation, labor, medical triage, privacy, reproduction, property, emergency authority, scientific access, industrial priorities, and contact with Earth institutions would all become unavoidable. A lunar base might begin under a space agency, a coalition of states, a private corporation, or some hybrid model. But once enough people live there long enough, the question changes from who built the colony to who governs it. That question becomes sharper in an environment where survival depends on cooperation, and where infrastructure is so critical that political disagreement can never be entirely separated from physical risk. On Earth, institutions can fail locally, while people often still find alternate support in the surrounding environment. On the Moon, governance failures could be magnified by the fact that there is no outside buffer. Conflict over air, water, access to vehicles, medical capacity, or power distribution is not symbolic. It concerns immediate life conditions. This does not mean lunar society would inevitably become oppressive or unstable. It means only that the Moon removes many of the slack margins within which political systems on Earth absorb error. A bad administrator on Earth can be disastrous. A bad administrator on the Moon might be catastrophic. Even the ordinary tensions of hierarchy, inequality, and bureaucracy would carry unusual force when the governed population lives inside machines that must continue working in order for anyone to breathe. There is also the problem of meaning. Human beings do not live by air, water, and calories alone. They need privacy, beauty, leisure, ritual, memory, and some sense that existence is more than maintenance. On Earth, these things are often drawn from abundance of environment: trees, weather, streets, seasons, animals, food cultures, public life, accidental encounters, and inherited forms of place all contribute to psychological depth. A lunar colony would begin without most of them. That absence could become a profound emotional strain. What counts as a park on the Moon? What counts as solitude in a pressurized settlement with limited volume? What counts as festivity when the environment beyond the wall remains lethal and the supply chain remains fragile? Even if screens, plants, shared meals, music, and ritual life emerged, they would do so inside a setting where everything natural in the terrestrial sense has been replaced by deliberate simulation or careful preservation. A functioning colony would therefore need not only engineers and doctors, but artists, educators, cooks, organizers, designers, and people capable of making enclosed life feel human rather than merely survivable. Without that, the settlement might continue technically while hollowing psychologically. The Moon would not only test whether a body can endure there, it would test whether a culture can. And still, for all this, there would be moments of wonder severe enough to justify the attempt. The Earth hanging in black sky, the long shadows across crater rims, the knowledge of standing on another world, the possibility of scientific discovery preserved in ancient regolith and untouched geological records, the opportunity to build a permanent human presence beyond Earth for the first time in history. These things are not illusions. They matter deeply. But precisely because they matter, the counterweight must be spoken clearly. Wonder does not cancel hostility. Beauty does not reduce radiation. Grandeur does not clean the dust from bearings or restore a failed pump or answer what low gravity might do to a child over 20 years. The Moon's magnificence is real, yet it coexists with relentless practical severity. To ignore one side in favor of the other is to misunderstand the place. The nightmare, then, is not that life on the Moon would be impossible. It is that it may be possible only through such continuous technical vigilance that every ordinary human act must be defended by systems. To drink, to sleep, to travel, to grow food, to treat illness, to dispose of waste, to build a room, to raise a child, to survive a solar storm, to endure conflict, to keep despair from settling into routine. All of it would require discipline layered upon machinery, layered upon planning. A lunar settlement could succeed, but it would succeed in the way a fortress succeeds, not in the way a valley does. Dependence on Earth would remain one of the most humiliating truths of a lunar settlement, at least for a very long time. Much of the rhetoric around colonization speaks in the language of independence, self-sufficiency, and expansion, as though building a base on the moon were the first clean step toward a second branch of civilization. In practice, a lunar settlement would likely remain entangled with Earth more tightly than many dreamers prefer to admit. Spare electronics, specialist tools, pharmaceuticals, certain machine parts, advanced medical supplies, refined components, software updates, technical expertise, and perhaps even much of the cultural life-sustaining morale would continue to originate from the planet below. That dependence would shape psychology as much as logistics. The settlers would know that their world, despite all its heroism, remained an extension of another world's industrial surplus. A delayed shipment would not be a minor inconvenience. It could become a bottleneck affecting maintenance schedules, medical readiness, scientific plans, and confidence itself. A damaged valve, a missing sensor, a failed fabrication run, or a contaminated batch of supplies could ripple through the colony with disproportionate force because the margin for improvisation would be narrow. Earth would remain visible in the sky not only as homeland, but as the source of stability the colony had not yet learned to reproduce. There is something psychologically difficult in that arrangement. Human beings often accept hardship more easily than dependence. To endure a hostile place is one thing. To endure it while knowing that crucial parts of one's survival still arrive from a distant parent civilization is another. A lunar colony might therefore oscillate emotionally between pride and fragility, between frontier identity and the inescapable knowledge that it is still tethered, materially and symbolically, to the deeper abundance of Earth. Waste would become another defining reality. On Earth, waste can be hidden by scale. It is trucked away, buried, processed, diluted, exported, or forgotten. Even when these systems fail morally or ecologically, they benefit from the fact that Earth is vast, atmospherically buffered, chemically active, and biologically self-renewing on enormous scales. The Moon offers none of that. A settlement there would have to confront every output of human life with unusual directness. Wastewater, biological waste, packaging, worn filters, damaged parts, chemical residues, dust-contaminated materials, failed electronics, and even ordinary household byproducts would remain inside a closed or semi-closed survival economy. This changes the emotional meaning of consumption. Throwing something away would no longer mean removal. It would mean reassignment to storage, recycling, repurposing, or processing. The colony would need systems not merely for cleanliness but for metabolic discipline. It would have to become a machine for turning outputs back into inputs wherever possible, because every imported kilogram matters and every accumulation of unmanaged waste becomes both a hazard and a sign of systemic weakness. There is also a symbolic severity in this. A lunar settlement would expose the truth that civilization is never clean, only buffered. On Earth, the planet absorbs, disperses, and hides the consequences of daily life well enough that people can imagine themselves living without residue. On the Moon, residue would stay visible. The colony's technical sophistication would be measured not only by what it can build, but by what it can endlessly cycle without poisoning itself. Human life would appear in its full industrial honesty. Education would become a major question the moment a settlement tried to become more than a rotating mission. If children were ever present, or even if adults simply remained long enough to require cultural continuity rather than technical task completion, the colony would need schools in some form. But what does education mean in a pressurized habitat on another world? It cannot simply be a smaller version of terrestrial schooling. The environment would transform the curriculum at every level. Safety would be foundational. Systems literacy would be cultural rather than specialized. biology, engineering, resource ethics, emergency response, and the psychology of confinement would all become part of ordinary upbringing. Yet a colony cannot educate only for survival. If it does, it risks producing a brittle society whose imagination narrows to maintenance. Literature, art, history, philosophy, humor, games, and memory would matter precisely because the settlement would need something larger than procedure to justify itself. A child raised on the moon, or even an adult spending a decade there, would need more than technical proficiency. They would need a sense of belonging to a human inheritance broader than airlocks and repair logs. This is where the challenge becomes civilizational in the deepest sense. Can a society formed under permanent environmental threat preserve generosity of mind? Can it produce not only competent operators, but fully human people capable of beauty, disagreement, creativity, and moral imagination? A moon base that works is an engineering success. A moon society that feels worth continuing is a cultural success. The two are not identical. Religious life, mourning, and memory would also take on unfamiliar forms. Every human community eventually faces death, grief, ceremony, and the need to locate suffering within shared meaning. On Earth, these experiences are surrounded by inherited landscapes, burial traditions, climates, family networks, and symbolic geographies. On the moon, all of that would need reinterpretation. How does a community mourn in a place where space is limited, where biological handling is technically constrained, and where the dead cannot easily be returned to the soil of the world that shaped the species? The question sounds distant until one remembers that a permanent settlement would not be exempt from ordinary tragedy. There would be accidents, illness, perhaps suicide, perhaps conflict, perhaps deaths that occur not through spectacular disaster but through the same fragile biological fact that accompanies every human society. A colony would therefore need not only medical procedure but rites. It would need forms of remembrance that do not collapse under utilitarian pressure. It would need to prove that human dignity can survive even in a habitat where every cubic meter is calculated. In this respect, the moon would test whether human civilization can carry its symbolic depth into hostile places without flattening itself into pure function. A species that can mine regolith and recycle water but cannot mourn meaningfully beyond Earth has expanded physically without fully expanding humanly. A true colony would have to bring the invisible cargo of civilization with it, not just its hardware. There is finally the question of return. A lunar settlement sounds in rhetoric like a new beginning. But many of the people who would live there, especially in the early generations of habitation, would likely remain haunted by the possibility or impossibility of going home. Return shapes endurance. A difficult place can be tolerated differently when departure remains plausible. If return becomes delayed, expensive, politically uncertain, medically difficult, or psychologically painful, then the settlement changes meaning. It becomes less like a mission and more like a condition. For some, that may produce pride. For others, it may produce a kind of muted despair. Earth would remain close enough to see and far enough to deny. That contrast could wound more than greater distances might, precisely because the object of longing would be constantly present in the sky. A Martian colony is separated by enormity. A lunar colony is separated by nearness that cannot be casually crossed. It is the sorrow of seeing home while still needing machines, planning, and permission to touch it. This may be one of the darkest pressures of all. Not the obvious hostility of vacuum, but the emotional weight of suspended belonging. A person on the moon might build a life, do meaningful work, form attachments, perhaps even love the severe beauty of the place, and still feel, in quiet moments, that the real world is hanging above them in blue and white silence. That tension between commitment and homesickness could become one of the defining emotional conditions of lunar civilization. So the moon remains what it has always been, beautiful from afar, merciless up close. Its nearness flatters the imagination into believing that it belongs to the same emotional family as home, merely farther out. In reality, It belongs to the severe provinces of the universe, where life survives only by enclosing itself within its own artificial climate and carrying every necessity as a planned victory over environment. The moon is close, but closeness is not kindness. If humanity one day lives there in earnest, the achievement will be magnificent. It will also be an admission that our species has chosen to inhabit a place where almost every background condition of Earth has vanished. No breathable sky, no oceans, no weather softened by air, no magnetic shelter, no easy agriculture, no forgiving mistakes. The colony, if it comes, will stand as a monument not to lunar hospitality, but to human persistence. And perhaps that is why the moon exerts such lasting power over thought. It is the nearest proof that the universe does not become habitable simply because it is visible. The most familiar object in the night sky is also one of the clearest reminders that beauty and hostility often share the same face. To live on the moon would be to discover that lesson every day, beneath a black sky, in a shelter of metal and discipline, with Earth shining above like memory itself.